Can you hear me?
Yes.
Good. Good to see you. So far we are not many people. Maybe some. Yeah. Thank you. Yeah. Please let me know if I'm on mute or if I miss anything. I'm well. I'm not quite as prepared as I planned to be because I had to switch around a few things. So, well, it's a work in progress. So whatever isn't working today, I will provide you also with information and after the workshop. So, so you can prepare definitely for the datathon. So today we have the second part of descriptive analysis, which is supposed to be much more hands-on. So let's see, yeah, what we can do. And okay, so um, so oh, can you? Okay, give me a second. Here. No. Okay. So now you can see the slides. I hope. I opened my PowerPoint because, well, then I can maybe add a few things. Let's see. So last week, on Monday, we talked about a few basics and some on the levels of measurement in principle, which is a quite important classification for simple data, because basically if you know the level of measurement, you know which methods you can apply. This is true for descriptive statistics. So for the very simple graphics you can use or parameters you can calculate, but it's also true for quite a few of the modeling methods. So and inferential statistics. So if you understand if you know how to classify your variables, you know which methods you can use to understand and also for modeling. For example, for logistic regression, you need a binary, or for a linear regression, you need at least one a metric or quantitative variable. But also for other machine learning methods, you will have to look a bit around which is suitable. So anyway, today I wanted to show you at least some the most common methods you can use to describe data. And so we use to describe data, we use graphics and parameters. So all kinds of diagrams. I'll introduce the standard diagrams, but I'll also show you, or at least I'll give you a link to an overview of all kinds of visualizations that might be interesting and that you might need with different datas. And we'll also talk about standard parameters. I guess most of them you will already know. Let's see. So what you can do, so which graphics are necessary or useful, or what frequencies and parameters you can calculate depends on the data. So, and you can structure your descriptive analysis. Usually you start with one variable and then you may group a variable. So this is the univariate analysis. And then you may group this variable by different other data. And then you can also switch to bivariate or also multivariate analysis. So in this only works, I mean, any of this, if you have like a countable number of variables. If you have big data, huge data sets with thousands or at least hundreds of variables, you can't really look at single data anymore. But if you have like a reasonable number of variables, for example, what you can see in this World Happiness Report, then you can really use diagrams and parameters to understand what is in the data set. And this is also a good preparation for the cases where you can't do this anymore, because maybe you're able to at least spot variables where it may be good if you look like manually, or if you don't do it manually, but where you actually look at some graphics or parameters, even if you can't do it for all, or if you calculate it automatically, maybe you can spot some something that is inconsistent or that is interesting or surprising. So you can train yourself a little bit to yes, to what would you expect, and what could be interesting, or what could be off in the data set, in the data. So, and for the datathon, you will at least need to describe a few of your data. The data set will not be that, so will not have that many variables that it's completely useless to even try to describe it. So it will be something that you can at least try to understand, also using descriptive analysis. You can use R or Python or any other software or programming language. On Kaggle, you have the option to use Python or R. But most of these things you can even do in Excel, which is, I mean, it's not very practical or efficient. But sometimes when you only use, if you get data in Excel or in some kind of tabular file, and you just need one graphics, or you just need to calculate the mean, then you can even use that. So if it's just, one number, if you don't have to repeat this, it may be the easiest to do that. So the what kind of software you use, if you use, or which kind of language you use, doesn't really matter. You will find explanations for all of this in the internet. I'll give you some links for R and Python, and also I created an example R notebook in Kaggle, which is not yet in the datathon. A Kaggle, but we will get it in there. This is, I'm still trying to figure out how this works, because, usually I use R not in Kaggle, but it's working. So, and you will get an example notebook, so you can at least look at some example code, and I'll try to provide this also in Python. This is not usually what I use, but whatever I show you in R, you can also do in Python. And I'll give you you will find many tutorials on the internet, but I'll give you a very good page which provides example code for R and Python, and you can basically, whatever you need, you can quickly find. So, but the idea is that you have at least the basics, or an overview and examples in Kaggle in the datathon. So let's see. It won't be there tomorrow, but hopefully soon. Okay, so I usually separate descriptive statistics by categorical and by quantitative data. So last Monday and last week, Tanzim pointed out that ordinal data have a kind of a special place. There are, so if you go by certain typologies, categorical data, because you can't calculate with the values. The values are categories, but they're ordered categories. So sometimes what Tanzim also described, you have the typology as nominal data are the categorical data, then you have the ordered data or ordinal data, ordered data, and then you have the quantitative or numerical data. So there are different typologies around. It doesn't really, so they're not contradictory. It's just they may, set the focus somehow differently. So so you can use basically what to structure methods and data for yourself, you can use you can order it as is best for you. So I'll definitely point out that ordinal data or ordered data has a special place and what you can do with the different data types. So let's start with categorical data. That was um, the nominal or ordinal data. And here's an overview of what you can do with this type data types. So as this visualization for one variable or two, you can use bar plot. So for one variable, you can use a bar plot. That's basically it. In principle, they are pie charts, but please forget about pie charts. I should put it here. They're not. There are reasons why they are misleading. There may be a few examples where it's okay to use them, but in principle, whatever you show in a pie chart, you show better and more objective in a bar plot. Okay, I should. So if any somehow possible, so I'll don't use this. I'll put a link. So anyway, so if you have two variables, you can use a Mosaic plot. And I'm not. This is something that you may not have encountered. I'll show an example in a second. Well, soon. So. You can calculate or provide frequencies. So proportions, you can provide relative frequencies or absolute frequencies. So the counts. So that's basically what you can do with nominal data. And so there's, apart from the mode, so the most common category, there is no statistical parameter you can provide. Apart from these frequencies. For ordinal data, you can calculate or you can provide robust parameters. I'll come to that later. These are, maybe you know that the median and all quantiles. Maybe you know the quartiles. And this is out of range now because of the pie chart. And you can also provide as a dispersion measure the interquartile range. Do you know this, or does anybody of you know these parameters, or is this all new to you? That's great. If it's new to you, so this is really standard descriptive statistics, so you can read up on it everywhere. And it's not so yeah, it's not that difficult to understand, and it's yeah, that's great. And if you and as a correlation for ordinal or order data, you can calculate rank correlation. This is correlation, the Spearman correlation. And again, for many of these methods or terms or parameters, you will find different different terms. It depends a bit on the field or the background. And so if you're right now in machine learning or descriptive or more statistical analysis, but so try to, so you basically should use the terms that are standard in the field, but you don't have to learn everything anew, because there is definitely overlap. And if you just understand that, okay, somebody else calls it, well, the first quartile may be called the 25% quantile, or the sometimes it's the you prefer upper and lower boundaries for quartiles or quantiles. So it's just a different way to name them. So before I show you an example or examples in Kaggle, so in this R notebook, I wanted to point out one very important problem that can occur. So what you should be aware of. So this is one logical fallacy that is not uncommon. So I hope so you can avoid this if you just think clearly. It's called the confusion of the inverse. So if you provide relative frequencies, you only have the the proportion or the percentage, but if you don't know what is the total, so the total amount, the total number, then you don't know how many observations are behind these relative frequencies. And if you don't know what is considered the total, so which group is equal to one to the whole, then these relative frequencies are basically meaningless. So what you always have to understand and know for what you are calculating or providing relative frequencies. So if this goes wrong, it's called a confusion of the inverse, or a conditional probability fallacy, or the inverse fallacy. That happens. Oh, actually, I'm sorry. The problem arises when the logical fallacy is actually when one conditional probability is equated with its inverse. I'll come to that back. So, but that's the usual problem. Nevertheless, you also need to know for what you are calculating these relative frequencies. Let me give you one example, which is from Germany, but I'll provide all the data. So we have in Germany the what do you say, we have a chancellor on as head of the government. And since 1945, we had 10 of them. So now the 10th is governing. And one was female. You may know Angela Merkel, and 9 were male. So now you can provide the probability that the German chancellor is a man. And that is P equal to 0.9. Here, the reference group is the group of all German chancellors. So then the probability that the German chancellor is a female or is female is 0.1. But the probability that a German man is is a chancellor in Germany is 0, because then the reference group are all German male. Maybe now, or maybe since 1945, it doesn't really matter. It's a larger number. Right now we have, I should have, so right now we have a population of approximately 83 million people. So let's say half of these are male, then we have here something like 41.5 million. So if we divide not 9, these are all male chancellors, by 41.5 million, then it's equal to 0. And it doesn't really now matter if we take all male that are alive now, or if we take all grown-ups, so all adult males, or all adult males since 1945. The total number of chancellors, of male chancellors, is in comparison to all male pretty small. So the probability is 0. So if you turn this around, if you look at the probability that the chancellor is a man, you're pretty close to a probability of 1, but the inverse, the probability that a man is a German chancellor, is 0. So this probability is not the same. And here the difference is extreme, because the groups, the reference groups sizes are so extremely different. But in other cases, it's not that clear on first sight. For example, if you have the probability of, if you have a test for a disease, doesn't have to be corona or COVID. So if you have a test for a disease, the probability that the test is positive, showing you have the disease, if you are sick, or if a person is sick, is not the same as if that the test is positive in the whole population, where you have people with and without the disease. So it makes a huge it makes a difference what is, or the probability that you have the disease when the test is positive. That would be again this logical fallacy that if you have a conditional probability, for example, test is positive if you're sick, or in case you're sick, or you're sick given that the test is positive. So that is in the inverse probability is not the same. So this is something you always have to make sure. Usually it's helpful to also provide the absolute numbers, at least of, let's say, the total set or sample, so that you have an idea of what is behind, so what group size is behind the relative frequencies. Yeah, the context is very important. So for example, if with relative frequencies, you can easily compare. So for example, we could compare, let's say, the percentage of people entering university, or percentage of computer science, women in the computer science in different countries, let's say in Bangladesh, Germany, Australia, and USA. So we can compare this, and it's and then we have an idea of maybe the number is highest in the US. So the frequency, the the percentage. You can give the proportion, then you just divide by 100, then you have the proportion. But obviously the number, the population is very different in the countries. So the absolute number behind, so how many, I'm sorry, I have to. Okay, möchtest du da einmal schauen? My daughter is here. Gut. Was ist los? Jetzt kurz hier bleiben. Okay. Okay, so she's staying for a bit. So if we would compare the absolute numbers without any other context, then this is not very helpful, because obviously, so the absolute number of students in computer science in the different countries, this is also without context, because what is interesting, what I guess is, so the absolute numbers are also interesting, but it doesn't really help in comparing if the percentage, if the relative frequency is higher or lower in different countries. For that, we need these relative frequencies. But if we want to know how many people or women are behind these relative frequencies, then obviously we need the size of the population. So we need counts. We need how many, yeah. And we can have different comparisons. We can, for example, say percentage of all female students, or percentage of all adult females, or percentage of all females in STEM. So there are different options to compare, for which we could compare relative frequencies. And this is something. This is so just always think about what you're doing, and if you get numbers or frequencies, think about what they mean. So just see if you have all the information that you need. Okay, so now so at least I'll try. I'll show you some. I'll show you this in in a Kaggle notebook. Let's see how this goes. So where is it? Yeah. Ich brauche noch ein bisschen. Magst du mit Justus spielen? Oh, sind die weggelaufen? Achso, magst du da hingehen? Oh. Okay, so here I created one notebook. I chose as you can choose as code somewhere here language. I chose R, and I stack its code. But you can use Markdown, which may be helpful. I'll have to try what is more suitable. So if you start this, what you see is the R environment, and immediately you get the option to have Tidyverse, which loads all kinds of packages that are listed here. At least some of them we will actually use. I think I'll have to start this again. So you can run the code. So each chunk of code by clicking this arrow. Maybe there are better options. I don't know. Okay, so where is now the? Oh. Let's see. Okay, so session info gives me all the packages that are loaded. Okay, so some are from down there because I'm still in the session. So, but with Tidyverse, what you load is, for example, Dipla, which is very helpful, and ggplot2, which is basically the package I use for graphics. But there are other options, and if you use Python, you basically can do the same. So this package, for example, is for color, which I use further down to as an example. Okay, so this is just so here I load the World Health Report, the World Happiness. Not health, happiness report data, and I will not load Dipla and ggplot2. So usually I would have to do this because, well, usually I don't load Tidyverse. So the data should already be loaded, but I can override this. So I use this. If you can see the notebook, I mean, these formulas are functions are pretty standard, I guess. Even if you don't work in R, with R, you will be able to understand most of them. Where's the camera house? Give me a second. Okay, so my husband is in a meeting as well. Okay, so yeah, it happens. Okay, so with view, you can see this kind of tabular overview of any data. So this is just very helpful. If you just load a data, you can just have a look at it and you'll get some information. So if you have already looked at the data set in the database, then you will at least know some of the. Kannst du unten bleiben? Okay, pass auf, dann setzt du dich hier hin. So, aber lass mal deinen Kopf hier. Okay. Okay, so you will know at least some of these variables. Structure, so these function str is also very helpful because it gives you an overview of the data, the structure of the data. So we have here 1,945 observations of 11 variables. This is not big data, as you can see. And it's 190. It's close to 2,000 because we have the happiness report of different years in here. So this is the variable year, and you can see that we have, well, several years. So it's the countries appear more than once in this data set. Yeah, you see the variable names and the variable type in R. You can change all this. So here, this is also the point where you have to make sure that this is correct. As Tanzim showed you for the database, when you read in data or if you migrate data, you also have to check if if the data type is okay, if it works like this. So if R sees a number, I guess Python is the same. It's considered numeric or integer, or it's quantitative. But for example, you can the variable country name. You can provide a string, but you can also number the countries, and 1 to, I don't know, 200. And then if you read the data in, R will see numbers, and it will say this is a quantitative variable, probably an integer. So then you can change back. So you can leave the values if it's more useful that you have a category as a number than as a long string, which saves space, and so it may be very useful. But you can still switch around the variable types. So this is something. So the reading in stage in any kind of program of the data. So this data preparation to make sure everything is okay, and everything is as it should be. This is very important. So I often have students who have, who calculate then the mean for, for example, for place where they live, or how do you say, if it's urban or country, for example. So then they have a mean for the sample that people, the mean is that they live 1.75 somewhere between city and country, which doesn't really make sense. It's also a little bit funny if you calculate the mean for gender. So you make sure that you understand the data. Yes, so in the chat you see a question, can I switch a category as a num in Python 2? Well, I'm pretty sure you can. If you have, so what you see here in the first for country name, it's Afghanistan, and then come all the other countries. So here are some. So if you have a string, that this you can't change to a num. To numeric. But if you have numbers, for example, if you first change, Afghanistan is 1, and then Zimbabwe would be, I don't know, 200 or 196, or it's 166 countries, I believe. I forgot. But so then you just number, and you just go from 1 till, the last category. Then you can easily switch this to adjust the variable type, or maybe it's called object type. I don't know the term for Python, but yes, you can change. So in R, it's functions like what I show here, as factor, as numeric, as a character, as integer. So these are the functions to change the variable type, but in Python you will find similar functions. And if I manage to provide this in Python, then you will at least see one example. But yeah, it's a typical task. So if you look at these data types and variable names, and you want to change, sometimes this makes sense. Then you can, for example, use functions like as factors. So I create here now a temporary world happiness report out of my world happiness report. So basically, I'll take the world happiness report, which you see here, and then, so this is the pipe in R, in Dipler actually, in the package Dipler, and then I mutate. I use the function mutate to change the name of the variable country name, because for me, I think it's too long. So I'll shorten it to country, which is still very long, but at least we understand what's behind this. And I want to go from character to factor, which I do here. And then I can also just change the names of some other variables. So for example, live letter is now letter, and this very long log GDP per capita is here now log GDP, and so on and so forth. So you can go through the whole list and change as is more sensible for you. And so if we look at this, what's happening here? Okay. Now we have 17 variables because mutate creates a new variable out of the old one. So it basically adds. So there are also other functions. Maybe in Python, this is a standard easier, but here the typical thing would be to then just select to pick out the variables you are interested in now. So with select, I basically get rid of the old variables with the old variable type and name, and I just chose a few here because yeah, as an example to show you some things. So again, so here I have now the World Happiness Report 2, which I use, and with 7 variables that you see listed here. This is again the structure of the data set, and with a summary, which is also, well, it's a very useful function, you get also an overview of the data. This only works if it's not 100 or 200 variables. So yeah, you have to see when it's still when you still can use it and when you can't. So for each of the variable, you get here some for the quantitative variables, you get some parameters: the minimum, the first quantile, the median, the mean, and the third quantile. Third quartile, I'm sorry, which is the 75% quantile. So these quantiles divide all the data, so all the observations in sections. So you order them by value, and then the median, for example, it's the 50% quantile. So the median divides all the observations by half. So smaller than the median are 50% of all observations, so smaller or equal, and larger from the value are the other 50% of observations. And the first quartile, which is the 25% quantile, is respectively the value for which 25% of all other values are smaller or equal. So 25% of all other values are smaller or equal to the quantile, 25% quantile. So you can use this to divide the data in, yeah, so example in quarters, or by half using the median, or any other percentage you can think of. For example, often also the 5 or you could, for example, give the 2.5 and 97.5 quantiles, and then you would have the inner 95% of all the data of the values. So you can use these quantiles to cut off, the how do you say, the regions on the outsides. And then the maximum. So these are, well, basically standard parameters that are usually given. All are location parameters, so no dispersion is provided. But you can use it to get a first impression. For example, looking at the year, we know that the data is for year 2005 till year 2020. Or that the healthy life expectancy is between 32 years and a little bit, and 77 years. So there's this huge range of different healthy life expectancies in the different countries. So that would certainly be something interesting to look at. Which countries are closer to the max and which countries are closer to the min. So where are the largest differences? And is it correlating, for example, with the GDP or freedom or support or something like that? And for the categorical data, you get, basically, it's the number of occurrences here, which for these countries is the same. So it's just listed alphabetically as far as it fits. So there are many other countries here, obviously, after Cameroon. But these first few countries appear in every year, obviously. No, actually, it's 16 years, right? So it's 1 year is missing for each of them. So going on, with categorical data, you can show them in a bar plot, and I'll give you an example here. I use Ig Plot. I use this data set, the second World Happiness Report that I created above. And with this aesthetics, I choose my variable. So the X variable, it's country here. Country is categorical or nominal, so I can use a bar plot. And with Ig Plot, I choose the type of plot with plus and then geom bar. So there are different functions that also provide a bar plot in R, and I'm pretty sure that in Python you also have different options to create the same graphic, or at least a very similar graphic. So yeah, you have to figure out what you like, how you like to create your graphics, and this is something you can look at before the datathon. So some standard graphics, how you like to create them, some standard parameters, how you like to calculate them, because also there are different options you can use in R and in Python. So what we will provide you with some examples that definitely work, but this is not the only way to get to get diagrams and to get parameters. So actually, let me write down something. I wanted. Okay, well, I forgot what I wanted to remember. So if you look at this bar plot, is this useful? So this is the bar plot of all the countries in the data set. Is this helpful? No, exactly. It's just too many categories. So we can't, this is, not useful. If you would if you definitely need a bar plot of all these countries, then you could turn it around and make it a very long, make it horizontal, which might help because you may be able to at least read the country names. But often if there are just too many categories, it doesn't make sense. So you don't so graphics and diagrams should always be helpful. So if they're not useful, if you can't see anything, if it doesn't help you understand, then just do something different. So maybe another diagram is helpful. Maybe you can't visualize. So what I did here is, as an example, here is a bar plot of the years. year is obviously not a nominal variable, but if a quantitative variable is discrete and has not too many values, different values, then you can also use a bar plot. And so here you can at least recognize now we have year 2005 till 2020. I can increase the size so we can read a little bit better. No. I'm sorry. I need this theme. So with ggplot2, you have different themes that make that look a bit, well, that look different and maybe prettier. So you can choose. So this is one standard theme. That's the theme black and white. But there are others. I give some examples further below. You can choose what is well suitable to you. Anyway, here you see I increased the label size, the font size, and here we can at least see all the years, and we see that for the year 2005 and 2020 there are fewest data. No, actually 2005 and 2006. And like most data, so data for most countries is available in between 2011 and 2019. So this is something which we see now from this bar plot. There was a tip in the chat that with run all we can run the whole code at once. And yes, you can, and if you probably also should. And I use this. Let's see what I still go here through this now one by one. For the next workshop I'll think about if it's more helpful if I do it, if I have it ready. Anyway, so for the countries, as you could see, it's not useful at all. So with here with this choosing the data and specifying the variable, I can print all the all the all observations for this variable. Obviously, several countries occur more than once. With the function unique, I can print all categories that occur, but only once. So you have an overview here of how many countries are in this data set and which are in the data set. You can count as well. So I could now, well, let's do it in the next. So using the function unique and then count, I can, well, no. This is missing. No, what did I do? Okay, so obviously for factors, since I changed to factor, it doesn't work. I thought actually, okay, well, somehow you can count how many. Okay, with the levels, I can just look at how many levels occur. Anyway, so since these are too many countries and I can't look at all of them, I can choose. I can filter a few and analyze those. And this might be helpful also for other variables. I have, well, I chose a number here. We can add another one. I went with Australia, Bangladesh, Chile, Mexico, Germany, United States, and Zimbabwe. So I think every continent is well represented, and at least the countries from which most of the students or the participants come. So this is now my third happiness report data set. So where I only, well, I filter out only a few countries which I want to look at in detail now. So if I do that, And then I have another bar plot of only variable country, but in this new data set, then I see this. It's not very exciting, but you can see it's Australia, Bangladesh, till Zimbabwe. So country and count, and it's not very exciting because basically all occurred 15 times. So data for 15 years is available. Only for Australia, it's 14 years. I can change the theme and and the size, and can get rid of the grid lines. So this is what you see here. Now the names are on top of each other. I can also change the angle, so then you have, well, at least you have now a nice bar plot. You can change colors as well. You can change also the width of the bars, which, well, I usually don't, but it's certainly an option. You can provide a title, you can change the labels. So whatever you want to change, you can. And yeah, here's another example. This is now bar plot of year again. And this theme is called classic theme, where you have this only, well, you have this open design. So I filtered all these countries out, or I filtered a few countries, but the levels are still present in the data. So the data set has still, well, a record of how many countries were in the data set and which they were, and I can drop these levels using this function, which, well, if you do filter, it might be necessary to do this, but this is also something you will see this if you do this with R or with Python, and you encounter some kind of problem, then you will know what to look for. So I can use table to look at absolute frequencies or counts, and I can use, so this is a function that simply provides counts for one variable, or for two, if you want to look at, if you want to group. Okay, let's do this first. Interesting. So it looks like this. So this gives me now, and if I don't drop the labels, then I will get basically for all other countries 0, because they don't occur, but they're still, so to speak, present as a factor, as a level in the data set. So that's why I had to drop the labels, because otherwise it would have been not very nice to look at. Anyway, we see the counts. You already saw them in basically in the bar plot. So so visualization is extremely important, because we can see and differentiate and compare very, very easily if we can see, for example, a diagram. On the other hand, it's not quite as exact as a number or a value or a parameter. So some decades ago, it was not very common to have visualization, also because you basically had to do it by hand, let's say at least in the 60s, whereas you could more easily calculate the mean or the minimum maximum or quantiles. And there was also this reasoning that parameters or statistics are more exact, because you have a number which you calculate it. You can calculate it up to the, I don't know, 10th digit. If you, it doesn't make sense, but you can. So, but on the other hand, so what you should always keep in mind, these numbers, so the parameters, they can be misleading. So if you think about the mean, if you have the mean of a distribution, let's say the mean of age in, for example, in this group, I guess it will be something around, I don't know, 25 or something. If you look at the mean of the population of one country, it might actually be similar, but the minimum maximum will certainly differ. The dispersion will certainly differ, because this group is basically all of them are adult. Most of you are students, or so it's a certain it's a certain group. Well, we don't have children or small children here, and also not very old people. But if you look at the whole as a population of a country or of any city or something, then you obviously have children, you have babies, you have teenagers, and you also have older people. So even if the mean is the same, the dispersion can be very different. You can provide, and you should always provide with the mean a dispersion, for example, a standard deviation. But sometimes it's still good to look at the data. For example, there might be so if you compare demographics, so one age group might be missing, or certain in so there might be differences that you can only see if you actually look at a diagram. So it's I wouldn't say that one is more important than the other, but certainly also not less important. And depending on whom you talk to, or which, I don't know, book you read, there might be this idea that maybe visualization is more important, or more often, I guess, parameters or the values, the mean and other statistics are more important. It definitely was the case some decades ago, and I guess nowadays most understand that both is very important. But then again, if you have big data, so many variables, then yeah, then you're stuck again, then because then you can't look at everything anymore. But at least at some things maybe. So here you have the counts, not very interesting here. Here you have the countries grouped by year, so you basically see in which year they occur. And in which year they are missing. So Australia is missing in 2006 and 2009, whereas all the other countries are missing in only one year, either 2005 or 2006. So that's basically it. So as I said, for this data set, it's not extremely fascinating to look at these counts. And now here, the relative frequencies, there are different options. So you can take the table of one variable and divide it by the length of this variable, so you get an idea of the relative frequency of country. Or you can use a prop table, which well,
can
yeah.
I ask a question?
Yeah.
Which line of the code is showing this table where we can say Australia 1, 0, which data are missing?
Yeah.
Which line of code is showing this table?
Yeah, you have to basically go by. So I couldn't really. So it's not really. As you basically have to know where to stop to look. You can. Just a second. Just a second. Okay. So because I used code and not markdown, and because I used I put some code in one chunk, you can't really see immediately from the output which is which, but it goes by it's ordered. So you basically, so the first table here. No, sorry. The first table here is this one. The second one here, grouped by year, is this one. It ends here. And this is the frequency, the relative frequency table. So also the comments are not printed. So I'll see if it goes better if I use Markdown or I simply use different chunks, but I put it in one chunk because it kind of belongs together. And you can use it to try out with different data sets or also with this data set, and then you can write your own chunks. So you can divide in a way that you understand what's going on there.
Did you use logical codes like, and so it's showing 0 or 1, false and true if
No,
it's
this is
there?
yeah. No, the reason for this is that no, it's not well, it is maybe logical, but it's not logical code. The reason is that each country appears in each year either one time or none at none time, no time. So that's it's just a coincidence. So it's just because of this data. So for each year we have data for for each country. But so for example, Australia, we have the happiness report for 2005 and 2007, but not for 2006. So you
Yeah,
get a
I
one.
got that point. And I just
Yeah,
wanted to know how does this output comes from arguments?
I can
If
show you. So here you can
yeah,
see different counts. So I didn't. It's just the number of of it's just the number of times for which Australia appears in 2005, which is it is one. And in
okay,
total it appears 14 times in the whole data set. So if you count now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it's if you reach 2020, it's 14. But let me show you. Well, I think I have another. I haven't really started here, unfortunately. I'm sorry. Okay, so let's try with
can
this
we do it
data.
in Python? If you
Yes.
know.
Yes, I'll provide a notebook in Python. I hope I can provide until next week,
Thank you so
because
much.
you can just also look up relative. You can look up how to get tables or so a table of relative or absolute frequencies. But let me see to make this more clear. Which so first, okay, so the count table. So we want a table that is. So because this happiness report data is, at least when it comes to the categorical data, not extremely fascinating, I used another data set here. It's UN data. And I got this from an R package. So in R, you have R provides many data sets, sometimes from the so just with the normal distribution, but there are also different packages with data sets. And all these data sets you can also get as CSV files. So you can also use them in Python. So it's you can switch. But anyway, so here there are hundreds of data sets. Many of them are pretty old. So it's not new data, but I use this as an example, data from the UN, and it's in the R package car data. So I have to load the package car data, and I can load the data in R with data UN. You can find all these data sets in R on this website. I'll put it also in the presentation. And there you find also CSV files. So if you use Python, you can just take the CSV file and use that. In R with question, you get information of functions or data. So if below here you have some information on this data set, and with structure, again, you get data. What you can see here it's a data frame with 213 observables, and it has different regions. And the regions are basically the continents. So if I put this in a bar plot now, if I show the countries, the regions in a bar plot, then I see this. So this is the number basically of countries in each region. So and to show to show a count table, I can use so I want to use region, which you see in the bar plot, and some other variable, let's say group. The group is here whether or not the country belongs to OECD. But it's just an example for now. So let's see how this looks. Okay, so now you have the table here. So it's the regions. Well, it's not by continent, but close enough. And you have the categories OECD, other, and Africa. Actually, no African country, at least at that time, was part of the OECD. So that's why it can be a separate category. So now you see the counts of, for example, for countries in Africa, whether or not, so for OECD, we have null, for other, we have null, but for Africa, we have 53. And in Asia, for example, we have 3 countries being part of the OECD and 47 other, and none in Africa, which is logical. So this, for the rest of the regions, Africa is always 0, because obviously only African countries can be in the group Africa. But here you can see counts which I created the same as for the World Happiness Report, but it's not logical. It's just really the absolute counts. And if you want relative counts, you can use this prop table, where you first create a table like I did, and save it or store it somehow. Well, you just give it a name, which makes sense to you. And then you use a prop table, and you get the relative frequencies. And here you see the relative frequencies for the World Happiness Report for countries, for these 7 countries grouped by year. And well, the numbers are not interesting. If I round these numbers, you see that it's either 0.01 or 0.0. It's just because the data is like that. So it's nothing very fancy, very surprising. But if I use again this a little bit more diverse data set, so okay, call this okay, I have to, so I can store this. Okay. So, and this rounding, I'll leave B for now. Let's see how it looks. Okay. So, okay, these are the frequencies now, and they are grouped by this group, OECD, other, and Africa. So here you have to consider this is 1. So the columns is 1. If you look at, for example, the country Africa, and if you look at the row, this is not, if you add the relative frequencies for Africa, for OECD, other, and Africa, this is not 1. So the reference group is OECD, other, or Africa. So you can see how so what is the proportion of considering the group OECD of African, Asian, Caribbean, European, and so on countries. So this is what this relative frequencies tell you here, if you group like in this way. And maybe it's still good to round this, because it's a bit much information. So I'll round a 2-digit with a 3-digit, which may be a little bit too much, but let's see. So this is here you can see how often how frequent a country or region is in group OECD, other, or Africa. If you switch this around, which you can also do, you can change the grouping. So now the reference group would be region. And if you look at that table, then it looks like, if you compare this, now you see for Africa, what happened here? it doesn't add up to 1, which so then there must be something missing. Maybe some countries are not, or some regions are not associated with any of this, because otherwise it's not correct. Well, it simply is not correct. What did I do here? Okay, let's take this out. I'm sorry, I have to check this. This is not right. This was wrong. So it should, you should, anyway, in these tables, you should always see, so something didn't go right there. In these tables, you should always be able to see what is reference group, and you should always pay attention to which, so basically the columns should add up to 1. So that's, well, usually I use a different package and I have a bit of different code. So I don't know, maybe something is working here much differently than what I thought it is. Sorry. Okay. So that about the categorical variables for now. Here is one Mosaic plot for which I also didn't use the data that we have so far, but admissions to Berkeley. So do you know a Mosaic plot, which can be very helpful? Okay, well, if it does, thank you. I'll check in the chat. Thank you. I'll check, and before I give it to you, I make sure that it's correct. Or if I miss something and you observe something, please get back to us. I mean, whenever you see something. Anyway, do you know a Mosaic plot? Have you seen this? These can be very useful. So with a Mosaic plot, you can present 2 or 3 or even more, but if you group usually categorical variables, and the area of each box tells you something of the size or the amount, how many observations are part of this group. So this is a bit of a standard example. It's admissions to the University of California in Berkeley. It's old data, and if you see this, we have a gender, male and female. So there are fewer applications by females, but it's data from the 70s, I believe. So it's old data. And here you have data rejected or admitted. And what is noticeable is that obviously, if you look at this, more females are rejected, or fewer females are admitted than males, relatively speaking. Also, absolutely, because there are in total more males if you look at the width of the boxes or bars. But relatively speaking, so you have here the Mosaic plot provides you with an estimate of the absolute and the relative frequencies. So there was a, I think it didn't happen, but there was a lawsuit filed if there is discrimination in admissions. It's actually not, because it depends on the department, but this is some paradox on what you also may often observe, that if you have aggregated or grouped data, some of the correlations or some of the differences or percentages or relative frequencies you observe change depending on whether or not you aggregate or you group. Aggregate, so if you group by a covariable which influences basically the frequencies here of the other 2 variables. And for example, here for this admissions, if you group by department, what you see is that with certain departments, the rejection rate is extremely high, and those were preliminarily the departments where females would apply. So they were, and in these departments where the rejection rate was so high, the rejection rate was not higher for females. Actually, it was partly also even lower than for males, but simply because they applied obviously mainly to departments with only few admissions, more were rejected. Okay, so this is just to show you a Mosaic plot. I will also provide the group version so that you can see no discrimination in this case, which I haven't done so. So there's a questions of percentages data. Is this because I switched between relative frequencies and percentages, or is this another question? So if you have relative frequencies or proportions, you basically say it's, well, 0.25 or something of the whole, but you can also always give it in percentage, 25% in this case. Yes, exactly. Well, the Mosaic plot is it's actually very useful. It gives you an yes, it gives you basically the percentages or the relative proportions between the groups, because the width and the height of the boxes tell you something about the relative frequency. So if you only look at the width of the box, you see how the x variable is distributed. So here the variable gender, you see that if you look at the width, that there are more males than females. It's not extremely so it's not much more, but there is a difference. You can observe this difference. And if you look at the height, you get the same information for the y variable, in this case admit. So you see the relative frequency between rejected and admitted, and but grouped by gender in this case. But still, you can see that in both cases, so in both groups, so the rejection, so more are rejected than admitted. And if you have more groups, you can basically see how it's distributed. And then because both the width and the height contain basically frequency or percentage information, you can also see that I guess this group maybe this group is from the count, from the observations behind it, the largest. But we can compare areas. Maybe this is as large because, you know, if you actually calculate, but we could look at the counts. Do I have the counts? If not, we can get the counts with the table. But let me show you, because time is, I guess, passing quickly. Here is at least one histogram, what I wanted to show you. This is data of the World Happiness Report, of the ladder score, and this is one. So this is a histogram of the ladder score. So the histogram is basically the standard diagram you use for quantitative variables. It gives you an impression of the I forgot the English term. So how the values are organized. No, this is wrong, but you can see this here. So what you can also do is I changed the x-axis limits because well, you can see the data basically starts here at a little bit above 2. So standard in general, the x-axis would start here not at 0 but at 2 and a little bit, which may be okay here because obviously the score 0 doesn't occur. But in some cases it might give you a wrong impression of the data, because we kind of expect axis to start at 0, at least for certain data. So it might be a good idea to be as objective as possible to change axis limits to something which is more logical or more easily understandable. So this is one thing that you can do. You can also use different themes. You can always change the size of the labels. So wherever you create a diagram, if you do it in Python or in R or in Excel or somewhere, make sure that the axis labels are readable and that they also make sense. So for example, maybe it would be nicer if I didn't write ledger here, because what does it mean? But let's say ledger score of the World Happiness Report. You can also give titles. So if you create diagrams for a report, always make sure that they're easily understandable and as objective as possible. So not misleading. So you can also, so what I did here is I also show the mean, which is the blue dashed line, and the median, which is the green dashed line, and I set a different bin width. So this is the standard bin width that R would give for this diagram. I guess Python has the same. I mean, you get a default, but sometimes it's useful to change this so you can try out different options. Here I chose a wider bin width. What is sensible, you have to decide based on the data and the values. Also, if it's sensible to start here at 0, I don't know, maybe not, maybe 2 would be good. Okay, so this is one of the most important diagrams for quantitative variables. Here are some parameters you can calculate using, for example, the summary function, which gives you, it's this first row here. It gives you the minimum, the first quartile, the median, the mean, the third quartile, and the maximum. So there is no standard deviation. You can calculate the standard deviation with SD. You can also calculate any other parameter with, well, there you have the function mean, median, IQR, and min and max, and so on and so forth. So you can calculate any parameter you're interested in easily. You can also use this Tapley or so tapply, a Tapley function with the summary option, which then looks like this. So here I use the ledger score. So I want the parameters for the ledger score, and I group by country. So it looks then like this. So I get basically the summary parameters, but for each country. So I can compare. For example, the minimum in Australia and Bangladesh differs, or let's say the mean also differs. Australia has the highest. Next comes here the United States, and then, yeah, you can look, you can compare. But what is also a nice function, I would say, is using group by and the summarize function. Then you get a table like this, which is also easily to compare, maybe a little bit more easy than having these single values here. So you get the country name and also all parameters that you're interested in. So you could add whatever your interest is here. And this is something that you can use to get an overview of different variables and compare the function. You can compare, for example, countries or other categories. You can round, and I'm not sure to get to reduce digits, and I'm actually not sure if I have to put it around here or somewhere else, but let's try it. If it doesn't work, I'll figure it out. So let's see. Nope. Okay, but you can. I'll just have to check how. Probably inside the summarize function then. Okay, so let me just Okay, let me get back to the slides, which yeah, are a work in progress as well. Okay, so we talked a bit more on the categorical data, and please look at this overview, which gives you at least an idea of what you can do. I'll see that it's all readable. So you'll get the slides, I would say, on the weekend. And we talked about this, how important it is that you think about for which what is the reference if you calculate frequencies, or if you read frequencies. This is even more important. If you get some kind of percentages or frequencies, always make sure that you know for which group or which this refers to. For quantitative data, there's also an overview. So you have different visualizations. I'll expand on this a little bit also in the notebook. So as I showed you, for example, for a year, you can also use bar plots. If you have, you can use this from, yes, you get the codes, you get the notebook, so you can basically take all the code, and as I said, I make sure that it's correct. If you observe that something is not correct, then yeah, just let me know. But for each parameter or a diagram, you get the code, and I put some examples and some things you can change so that you get at least an idea of what you can do. And I'll try to provide this as well, the same in Python, if you don't want to switch between R and Python. So I've worked for the last years usually in R, so I'm a bit more, so I don't know just like that how to do it in Python, but I know that it's possible. Oh, I'll show you a page where you can also get more ideas. Anyway, so you get the codes, and you can use this. You can use this also as preparation for the datathon. You should at least have a try something out with a few different data sets. I'll give you some more ideas. You can definitely use the World Happiness Report, but in some cases it's just not very, it's not a good example for at least some of these diagrams. So anyway, so the histogram I showed you, the box plot we haven't looked at. I'll provide this in the slides and in the code in the notebook. Do you know what a box plot is? That's good, because yes, it's very it's helpful. Let's see here. Okay, so let me just briefly, no, I'll go there soon. Anyway, so what we will also use often, or what you also need often, is a quantile plot. You may also know this, but I'll also give you some more information. And if you compare two, or if you depict two variables together, one of them at least quantitative, you can use scatter plot. So for quantitative variables, you can calculate all statistical parameters you can think of. So you have the location parameters, most of them you will know, it's minimum, maximum, all the quantiles, including median and quartiles, and mean and standard deviation or variance. So for ordinal data, you are not allowed to calculate the mean or the standard deviation. Especially the mean is often provided also for ordinal data. So this is a little bit of an ongoing discussion, and it depends a little bit also on how strict you are and what kind of data this is. But in principle, you cannot calculate with ordinal data because the intervals are not comparable. So, or they may not be comparable. I mean, this is the definition of ordinal data, that the intervals differ. So you can't, but for quantitative data, the intervals are always the same. So you can calculate and for the mean and the standard deviation, and any method that is in any way based on the mean, you need data for which you which is quantitative, which you can use to calculate. Yeah.
Can you give a concrete example from your own experience of when ordinal data can be used, or is just too awkward? Just something concrete.
Well, you often have, so I'm not sure which kind of grades you have in your country. In Germany, we have grades between 1 and 6, 1 being the best grade. And if we, for basically any exam that is written, we get the mean of, you know, all the students who took part in the exam, and then maybe the mean maybe 1.7 or 2.8 of the grades, which is good in our case. But grades are ordinal. So for example, when I give an exam, usually the fail part is if I look at the points, for example, for an exam, which I give points. The points are quantitative, but to decide whether or not a student passed or failed, it's basically the separation is more than or at least half the points must be reached. So basically the fail part is half of the points, and the pass part is also half of the points. But from the grades, this failed part is grade 4.3 till 6 or till 5, whatever. We don't need the 6 necessarily. But the passed part is separated in much smaller intervals from 1.0 to 4.0. So this means that if I look at the grades, so if I translate the points to grades, the intervals are not comparable anymore, because for the bad grade, for the failed grades, they're much wider. They cover a larger portion of the points than each of the past exams. But usually we do give the mean, and it is helpful because it gives an impression of, yeah, whether or not you're somewhere average or better, or a little bit worse maybe. It also gives you an impression if the mean is too bad, then maybe it's necessary to repeat the exam or to give another exam next time. Or if it's too good, then obviously something is wrong as well. Maybe wrong. That would be one example. And also in social science, you often have, you ask people questions, questions like, on a scale of 1 to 10 or 1 to 7, do you agree or do you not agree with the statement? This is a very common way to get information on different topics, because you usually don't ask people, do you agree with this, yes or no, because it's not very fine grained. So often you have scales, but if you agree or not agree is different for each person. So we don't have a metric in our head to decide, okay, this is now a 3 for me, so it must be a 5 for this person or something like that. So each person decides basically on their own. So this is definitely ordinal data. But in many cases, even for these kind of scales, the means are provided. And this would be one example, so
that is very helpful. Thank you.
Yeah. Yes, I'll try to provide also more examples in the slides, and also maybe here in the notebook to get an idea. But this is also definitely something that you can ask in the next weeks, maybe if you try stuff out, but also during the datathon, you can ask questions like this. For example, if you're not sure if you can or cannot apply this method, this is something you can definitely ask us. You can look it up, obviously. You can also ask, I don't know, your team members, but you should always, if you have questions like this, just ask, because well, one of the main one of the reasons is also for you to learn. So, okay. So yeah, and then so these location parameters, most of them you will know, but you'll get a list, and then you have dispersion. And this is also very important because when you saw this histogram, so this one single histogram, so it gives you an idea of how much variance is in the data and how the data is dispersed. And this can be different, even if you have the same variable, the dispersion can differ in different groups. As I mentioned, for example, the dispersion of the age will be different in this group, probably from if we look at everybody in the US of A or in Bangladesh. And if you compare, so also if you compare dispersion between different countries for different variables, you may also see differences, which may give you an idea or provide understanding. So, and then you have correlation. So these are basically the statistical parameters. Correlation is calculated between two variables, whereas you give location parameters and dispersions for one variable. And also the scatter plot is for two variables. Yeah, so basically scatter plot and correlation kind of belong to each other. And the scatter plot is the equivalent of the Mosaic plot for quantitative variables, so to speak. So there are always, yeah, you can have, if you understand these connections, this may also be helpful. So okay, so here's some literature that may be interesting. Most of this is actually in R, so so you may not be as interested, but something similar. You can, so they provide also an overview of what is categorical and quantitative data and what can you do with it. So it might be helpful to at least read this and then transfer it to Python. But this page or this website, Data to Viz, this is something that I want to show you. It's this page. And it provides a tree of different data types. And depending on which data, it gives information on what kind of graphics you can use to display this, to visualize. So, for example, if we look at one numeric variable, we can use here a histogram. There's also a density plot. You can see a box plot here. But if we go to histogram and click on this, you'll get links. So you get an explanation what it is, and can get some common mistakes. So this is also very helpful because common mistakes really means this is something that occurs often. Maybe not with you, but many of these graphics or visualizations you will also see if you look at information from other people. So for example, in the news or in reports, and this is something you need to watch out for, to look out for. Often, so there are obviously people who actively plan to lie with their data, and they can use visualizations and parameters to do that. But often it's not by by design or by on purpose, but just because somebody is maybe hasn't really thought about what they're doing. So it's just mistakes, and you have to, and they can be misleading. So you can, if you don't understand what's going on there, you can be misled by many things, by colors, by axis limitations, and so on and so forth. So this is something you need to watch out when you see other data, but also if you create your own graphics. Yeah, so anyway, this is always very helpful and useful. And then you have code, for example, R graph gallery, but also Python gallery. And if you click on this, then you reach this Python graph gallery, which provides you with example codes for really all graphics probably you may think of. So, and then you see here how to create, for example, this histogram, but there are other examples, and you can choose what maybe useful to you. So you have here, for example, a density plot together with the histogram. Here's a grouped version, and so on and so forth. So this is very helpful. So if you want to go on further and if you want to look at examples, this is really a fantastic website to click through. It's not the only categorization of diagrams. So this has this tree where you go by data type. So basically, if you know that you have a numeric or three numeric variables, or if you have categoric, or numeric and categoric, so or networks or time series, so you can go by data type and choose what you need from here, and then you get an overview, and you can click on further. It also provides basically a story or a history of other trees that are how do you say, other other categorizations of graphics and visualizations. So this is very useful, I would say, but they also provide other ideas that have been around and are still around. So you can look at the story and see what else you could use. Yeah, so that's that. And if I go back here. Okay, so I put the links here, but from this Data to Wisp website, you will find R Graph Gallery and Python Graph Gallery. And if you use any other language, you will also find galleries, I believe, at least if they're used for statistical analysis. Here, the book we mentioned in the Monday's workshop, Tanzim recommended this. I can also recommend it. It's interesting. It's sometimes, yeah, it's interesting, and it's sometimes a bit scary, but also it shows you, so there are things that are being done. So people are interested, women are interested in what is missing, what should not be missing, and there's really a world of possibility where we can, use data science to improve what we have right now. This website, Katie Nuggets, I would say, is this is a very helpful site which provides information on AI and analytics, big data. So this is something you can definitely also use in machine learning. So sometimes they are block, and so you can look at it. So I sometimes use it to get information on a method, but there are also some ideas. This is really it's really helpful. It's huge, and so it's not something that you just read in an afternoon, but you will surely find helpful information for different also data science concepts and methods. Also towards data science is helpful. There are many other helpful sites. I may add to this. I have to think about it because there's really a lot of information out there which you can use. But yeah, maybe you will find your own websites or communities that are helpful. Definitely Kaggle also provides, I should put Kaggle there, but we are anyway on Kaggle. So Kaggle also provides courses and data sets and informations, and you can look at notebooks and analysis of different people, so if they're open. And we will, I'm sure, add to the Datathon code, so you have some information there as well. Okay, so next week on Monday, Tanzim, I hope she is okay by then, will speak about, give an overview of data science methods. Until then, I will try to provide you with all the information and more what I gave you today. It's really also just an overview, but especially if I give you more code example, I think you may see some something valuable. and any suggestion is really welcome. So if you, I don't know if I can also, if you have interesting box plot or anything graphics, I can add this to the notebooks. So if it's something that is helpful to all, or maybe we can also add your own notebooks to, or you can share them, or we add them to the workshop. But definitely, if you think there's something I should expand on, or if you have questions, you can ask in Discord, and I'll try to include this also up until the datathon. So this is not nothing. We can add to it and yeah, in the next weeks. So it doesn't have to be all this weekend, which I will probably not manage. I'm sorry, the time is really crazy sometimes. But I will go on, and so you will get all the information that you're interested in.
Thank you so much.
So you're welcome. And are there any questions?
Thank you, Ada, Apo. And I want to know some that how will we get these slides or links or data visualization code you have showed today?
So the slides you will find also in Discord in the Google Drive as for workshop 1 and 2. And these slides will be for workshop 3 and 4 together, because they belong together. So you will get one set of slides for workshop 3 and 4. But like in Google Drive, like for the other workshops that before. But the notebook, I'll try to add this to, well, I think it's not a problem, to the Her Will Datathon Kaggle site, so that if you go to the, what is it? Let me just show you here. So, no. Where is it? So we have this, the Her Will Datathon 2002 workshops, and there's this overview that Tanzim already showed you. And here under code, I hope to be able to add this notebook, but I think I couldn't open it here. So you find the data here. And so this notebook I showed you, it's now in my account, but we will add it to the workshop, and then you will find it under code. And as soon as it's there, we will notify you via Discord, or I guess also in the next workshop we will mention this. But you should be able to see it here. So this will be something that you cannot edit but see, but then you can always copy and use it in your own notebooks. That would be the thing, how you will get the code. So you will have the slides and the code.
Okay, thank you. I understand.
Oh, the Kaggle link, yes. Yeah, we'll send the Kaggle link. I kind of hope that if you just have the link to the workshop, to the Her Will workshop or Datathon, that you will just be able to see not just one notebook, but several. That's actually the idea, but I have to make sure that this actually works. And I guess I need Tanzim's help for that. Yes, the Datathon link is in Discord, and this is what you see there. I mean, this is something you should be able to see. So the this site and so the description of the so the overview, and then the data is something you should also be able to see. And yeah, and if there is a discussion, obviously you could see that as well, but there is none so far. And there is no notebook, but there should be notebooks, and we will add them. Yeah, and now, so there's also some rules you can have already a look at and hopefully obey, and yeah, some other information. So this you will also find with other notebooks or analysis you can find in Kaggle. So you can look around. There's really a lot, an abundance of information. It's so much that you really have to look a little bit what is helpful and what is not. But you then also usually get an overview and the data and code. So this is just the common, so how it's structured. And you can see this also for other, competitions or other courses. Thank you. Okay, then if there are no more questions, then I'd say good evening, good day, and good night for now. And I hope you have a wonderful weekend. Please stay healthy. See you on Monday. And if there are questions, just send them via Discord and we'll answer them. And and remind us if it takes too long, but I guess one by one. And if we manage, if we don't answer, so if we didn't understand the question, just ask again. Just keep asking us. We definitely will try to answer any question you have. And so, okay. Okay, so then I'll say goodbye. Her will stop this meeting, I guess. And thank you very much for your attention and your questions and your participation. And see you soon again. Bye-bye.